Happy Monday of our second full week of school. That is, if you've been following our schedule correctly, it should be August 31st today. Hopefully the last 2 days, so Thursday and Friday, you looked at your interpreting graph notes. That was the vocab. And you did your function family graphic organizer, which was just copying the answers from the key. If you didn't, I suggest you pause my video right now and go to those last two things. You weren't required to turn anything in, but you did need to look at the vocab and fill in your graphic organizer from the answer key. Otherwise, today is going to be totally confusing and you're going to be so lost and so frustrated with me. So let's get started. This video is going to be a little bit longer because I am showing you how to use Desmos, which is your graphing calculator, to graph these different functions. So I'm first of all in Notability, but I think this will work with Canvas as well. I have Desmos down in that little, I don't even know what this thing is called. This, when you swipe up from the bottom, I have Desmos right there. So I suggest putting Desmos down there as well, because then you can drag it up and have a kind of a split screen. And mine kind of floats on top. If you don't like that float on top, if you hold that little gray dash, it's kind of underneath my red record button. If you hold that and drag up, it should split screen. There we go. Okay. Just kind of play around with it. I'm not very good at it. I'm sure some of you are like, Miss Sanchez, that was the easiest thing in the world. I don't understand why you had to struggle with that. Sorry, I don't normally split screen like this. Usually I just have it floating on top of my notes. So that's how I'm going to actually keep it as, because it's just a little bit easier for me. If you don't like this at all, if you don't like the floating over, if you don't like the split screen, you can absolutely just keep switching back and forth between the two different apps. Okay, so we need to graph this function. F of x equals 4 times the absolute value. That's what those straight vertical up and down lines around the x are. It's not parentheses. That's the absolute value of x. And then we're going to determine whether each function has an absolute maximum or an absolute minimum. And if you don't know what that means you probably didn't do the last two assignments. So if the graph has neither absolute max or absolute minimum, write none. We're going to classify each function as increasing, decreasing, constant, or if it's a combination, we're going to describe the combination. And then we're going to classify each function within its function family, which is linear, a linear absolute value function, a quadratic function, or an exponential function. And if you don't know what those words mean, you probably skipped the graphic organizer from Friday, and I suggest you go back so that you understand these vocab words, because this will be on your summative. And then we'll do a sketch of each graph, nothing specific, just a general sketch of the graph. Okay, so we are going to type into this first line. So click the first line, number 1, and I don't need to type in f of x. F of x is the same thing as y, if you're kind of confused. Y equals absolute value of x. And we'll get deeper into what f of x means, I believe, in second semester. So sit tight, wait till second semester, and we'll go a little bit deeper into what f of x means. But just for now, know that it is equivalent to y. It's just another name for y. And I don't even need to type in y into my graphing calculator line. So all I need to do is hit the 4, and then watch where the button kind of shades. It's this absolute value. See where it kind of got darker? It's right above the A, B, C. So I'm going to hit that, and then those two lines pop in. And then I'm going to hit X right at the top. And then notice there's our graph. How nice and easy was that? I can zoom in, I can zoom out. If I ever do anything funky, as you're playing around with this, sometimes students kind of get it like really funky, like this, and then they're like, I can't see anything. So if you hit this picture of a house, it's in your upper right-hand corner. If you hit the picture of the house, it returns it back to normal, to its default setting, if you will. Okay, so this graph, I'm going to sketch it first, even though it's the last direction, I know, but I'm going to sketch this just like that. It was a nice V. If you don't like these shaky lines, that's okay. Hold it, it turns straight. Hold it for a second, and it turns straight. I'll add my arrows on. Okay, first question. Determine whether each function has an absolute maximum or absolute minimum or none. So does this graph have an absolute top? Is there like the top of a mountain? That would be my maximum. Or does it have an absolute bottom point? That's my minimum. And this graph has an absolute bottom. The graph never goes below that red dot. So that is my minimum. That is my rock bottom. Okay, so we will write absolute minimum. The next part, classify each function as increasing, decreasing, constant, or describe the combination. If it's not always increasing or always decreasing, then it's a combination. So for this graph, and if you don't know how to tell if it's increasing or decreasing, we're going to start on the left-hand side of our graph. We're going to go to the leftmost point of our graph. Oops. We're going to go to the leftmost point of our graph, and we're going to follow it going to the right, okay? So from left to right, my graph is going down. So I am decreasing. Oop. I am decreasing. So if this was like a hill and I was walking along from left to right, am I walking downhill or am I walking uphill? I am walking downhill. And then I reached that red dot, which was my minimum. And then from there, what's going on from left to right? Am I walking up a hill or am I walking down a hill? And I am walking up a hill from left to right, so follow the highlighter. From left to right, I'm going up, so I am increasing. Oops. So classify how each function is moving here. Let me change my pen back to something bigger. So I am first increasing, then I'm first decreasing, then increasing. So decreasing, then increasing. And if you don't like to write on your iPad, you can absolutely type these answers in with this T button up at the top. Then you can type in on the keyboard. That would be totally fine. If you don't have a stylus, I know that it is really hard to write on your iPad. And then the last step, classify each function within its function family. So if you need to, you can absolutely go back to your graphic organizer for some help. But this was, this was a linear absolute value, and I know that because I had those absolute value bars. So if it has absolute value bars, it's going to be linear absolute value function. And another quick thing, I do like when you write out all of the words. Please do not abbreviate. I know that it's so much easier to abbreviate, but writing the whole thing out is going to save you a lot of confusion if you go back and review your notes and you no longer understand what your abbreviations are. So please write out the whole word. All right, let's go on to this second one. So I'm going to go f of x equals -4 absolute value of x. So if you want to, you can absolutely go like this. -4 absolute value x. Okay, and now we can see our new graph. It's in blue, and if you don't know which one is which, notice that right next to this first line that I have, it was red with like a little graph inside of it, and then my second graph was blue with a little graph inside of it. So the second one is the blue graph, the first one is the red graph. Okay, you could have also just gone back to this first one because it already has the 4 absolute value of x, and you could have just put in that minus sign and notice that it flipped the function. So by adding a minus in the front, it made it from opening upward like a V to now going downward like an upside down V. Okay, so let's quick sketch that. Change colors, and it was a V, open it like an upside down V was my graph. So the first question is asking us absolute maximum, absolute minimum. Does it have an absolute top or an absolute bottom? And this one has a tip top point, which is going to be our maximum up at the top. The graph doesn't go any higher than that. That point is the maximum. So we will write absolute maximum. And I'm going to get rid of this. I'm just going to swipe it to the right and get rid of my graph because I don't need it anymore. Okay, back to my graph. Increasing, decreasing, combination, constant. What's going on here? So as we go from left to right, so from left to right, did we walk up a hill or walk down a hill? We walked up a hill, so we are increasing. And then we reached that red dot, and from left to right, we went down. So we walked downhill, meaning that we are decreasing. So this function is increasing, then decreasing. And then which function family is this? Hopefully, you already know, linear absolute value function, because it was pretty much the same one as the first one we just did. So linear absolute value function. And my handwriting, notice, is going slowly downhill as we go. If you at some point aren't able to read my handwriting anymore, there is an answer key online that you can check to see what I wrote. Okay, next one, g of x equals 2x plus 5. G of x, don't get stumped. It's the same thing as f of x, which is the same thing as y of x. All right, so I'm going to clear these two graphs out. I just hit the X on the right-hand side to get rid of them so that I don't have a million graphs on my graph. And we go 2x plus 5. And notice now my graph is green, and I'm going to make a quick sketch of that. It's not intersecting my graph at the origin or the middle at the 0. It's slightly above that. My y-intercept is 5. So I'm actually going to draw this one kind of up in the air like that. All right. Do I have an absolute maximum or an absolute minimum? Is my graph ever reach a rock bottom, or does it ever reach an absolute top? No, it doesn't, because it's continuously decreasing over on this side and continuously increasing over on this side. It's never going to stop. It's continuing for infinity. So there is none. There's no absolute maximum, no absolute minimum. And as we go from left to right, am I increasing, decreasing, constant, or a combination? So if I put my highlighter on the left-hand side of my graph, I follow it from left to right. I went up, so I was increasing. And then what kind of function was this? Hopefully this one is the easiest one for you to recognize because it is a line, meaning that it is a linear function. All right. Next one, g of x equals negative parentheses 2x plus 5. Make sure that you include your parentheses. If you don't, it's going to totally change what your graph looks like. So I have negative parenthesis 2x plus 5. And just in case you don't believe me, if you just put a negative in front of the 2x, notice how the green line, which is the wrong one, is much different from the purple line, which is the correct one. So I'm going to get rid of this green line because it's incorrect. And if you're looking at my answer key, this one is incorrect on the answer key, and I throw that incorrect one on there to see if you're copying my answer key or if you're actually doing the work yourself. So I know if you're doing the work by yourself, if you have the correct answer. So I threw that mistake in there on purpose to see if you were cheating off of my answer key. So the correct graph should intersect your y-axis, which is the one going up and down. Oh, that kind of got messy. Y. So it should intersect in the negatives at that -5, just like the graph on our screen. Okay? So good job for you that are watching the video. You're going to get this one correct. Is there an absolute maximum or an absolute minimum? Well, this part of the line is always increasing forever. This one is going downward forever. So no, there's no absolute maximum or minimum. And if you're looking at the graphic organizer as you're doing this, in that linear function section on our graphic organizer, I said that there was never any maximum or minimum. Okay, so when you have linear functions, no max, no min, ever. All right, increasing or decreasing. Well, as I start on the left-hand side and I go right, I'm going downward, meaning that I am always decreasing. And what kind of function was this? Like I've already said, this was a linear function. It was just like the one we just did, except with a negative sign in it. All right, let's clear out this graph and go to our next one. This one has an exponent in it. H of x, which is the same thing as g of x, which is the same thing as f of x, which is the same thing as y, so don't get stuck up on that one. H of x equals negative, and then in parentheses, so h of x equals negative, parenthesis, x squared, minus 1, parenthesis. Okay, so let's type that in. Negative, parenthesis, x, and then to get the squared, there's two different buttons you can hit. You can either go to this a squared, so hit a squared, and it gives you the squared, or you can go a to the power b, which was right next to it, and it'll give you your cursor up in the exponent spot, and you'll have to type in 2. Either way, totally fine. Just make sure that you then put your cursor back down, so you just tap right next to that 2, kind of downward. Or you can hit the arrow over, either or, play around with it, you've got it. minus 1 parenthesis. Okay, so now my line is black. Notice that it told us that it was black on the left-hand side of our function that we just typed in. Whew. So this one's an upside down U. Okay, like that. The top is a little bit over the origin, or that 0 point right in the middle. It's a little bit above that. So that's how I drew it. Do we have an absolute maximum or an absolute minimum? Again, if you're looking at your graphic organizer and you're under quadratic functions, notice that this looks like a quadratic. That upside down U-shaped is quadratic. I told you that there was always going to be an absolute maximum or an absolute minimum. So do we have a top or a bottom? And in this case, we have a top. So this one is our maximum because it has a top. All right. And then are we increasing, decreasing, or some sort of combination? So as we go from left to right, I am going up until I reach that red dot. So I'm increasing. And then from that red dot, from left to right, I'm going down. So I am decreasing. So we have increasing, then decreasing. And then what kind of function is this? I already said it was a quadratic because of that U-shaped. You can also tell, let me write in function, quadratic function. You can also tell that it's quadratic because of this x squared. Anytime you have an x squared, it's quadratic. That's the dead giveaway in this one. And then as we're going through this video together, I noticed that I never gave you the fourth function family. So, bonus for you guys for watching my video, I'm actually going to go over an exponential function. So, instead of x squared, let's just cross out this whole thing. So, let's go m of x. I just made up a letter. M was the letter I chose. We're going to go 2 to the power x, and then minus 1. Okay? So this will give us an exponential function. I'm going to clear out my graph so that I can type this in. 2, and then I'm going to go A, B, so that I get that my cursor up in the exponent. Then I'll hit x, and then I'll hit over so that my cursor goes back down, minus 1. And if you didn't get that right away, if you couldn't figure out those, pause the video, rewind it, play around a little bit, and you'll find it, I promise. If not, email me, and I will definitely walk you through how to use Desmos, or hop on tomorrow when we have that open Zoom for you to ask questions. I will be available to help you out with Desmos if that's what you need. Okay, so we have it graphed. And we see kind of a curved line here. So that's what I'm going to draw in. And it goes through the origin. Okay, and I'm not the best sketcher here, so that's the best I got. All right. If you're looking at your graphic organizer, I said that exponential functions never have a max or a minimum. Okay. Well, as soon as I zoom out too much, it does look kind of crazy. Okay, so no maximum, no minimum, so none. Am I increasing or decreasing? Now, students, when they're doing exponential, they're like, oh, well, it's constant because that horizontal line looks pretty flat. But in fact, it is not. If we keep zooming in, okay, notice that it is super slowly going down, or as I keep zooming in, notice that it is in fact slowly, super slowly increasing. Okay, so this function is always increasing. It looks pretty flat, but I promise you it is not. It is always increasing. And then what kind of function family was this? I said it was exponential because that's the one we haven't gotten to yet. Exponential function. And you know it's exponential by looking at the original function because you have an x in the exponent, meaning that it's exponential. Okay, so that is all. I know that this one's kind of hard because we also incorporated Desmos into this. If you need any help at all, please feel free to reach out. If you are looking at that answer key, remember I told you I put a purposeful mistake in there and I changed this last one. So if you're checking the answer key, you will notice that it is different in those two different spots.